Good afternoon, distinguished jury members and participants. My name is Anas Torejan and I want to present you our project. So let's begin. Imagine a bullet traveling 20 times faster than a rifle bullet. Well, this is precisely the danger that our satellites and spacecrafts have to face every day. Nowadays, space debris isn't just an issue. It's something that can seriously limit our future of space exploration. Therefore, we present you our project, which is designing multi-layer armor to protect against large impacts from external debris, made by me and our teacher. So, let's talk about the threat. As we all know, there are millions of objects in Earth's orbit, from tiny particles to large rocket parts, moving at speeds of up to 15 kilometers per second. Even a small fragment at such speed possesses colossal destructive energy, capable of disabling expensive equipment or piercing through the hull of a manned spacecraft. But there is already an existing solution to this issue, which is the Whipple shield. It consists of two main layers, a thin outer shield that destroys the projectile and a main wall that absorbs the fragmentation cloud. There is also an improved field version of it with additional Kevlar layer. However, even this is still vulnerable to large projectiles and angled impacts. We decided we could create more reliable protection. Our goal is to design an armor that would work effectively as a unified system, with each layer performing its own unique task. So we developed the concept of 4-layer composite armor. The first layer is a hybrid disruptor shield. Its purpose is to meet the impactor and break it into many smaller fragments, turning a concentrated strike into a distributed one. The second layer is a two-phase absorber. We call it an energy sponge. It consists of material that crumbles or melts upon impact, absorbing a tremendous amount of energy. The third is a flexible composite shield, essentially analogous to a bulletproof vest. It's made of a high-strength fabric that catches any remaining fragments. And finally, the fourth layer, the most important for crew safety. It's a structure made of a shape memory alloy. It prevents the deformation of the inner wall and the formation of dangerous fragments inside the ship. So, obviously, conducting real-world tests of our armor is impossible for us. That's why we created our own interactive simulator. But this isn't just a simple animation. It's a real, fully-fledged physical engine that calculates the outcome of a collision based on real physical parameters like mass, speed, impact angle, and unique properties of each layer, such as density, hardness, and energy absorption capacity. So let me demonstrate you our simulator. So, as you can see, the name, Multilayer Armor Simulation, the visualization of every layer and the projectile, the settings. Here we can choose the projectile type, from steel, tungsten, and depleted uranium, but let's go with steel. We can choose the initial velocity, projectile radius, and impact angle. Let's go with the initial ones, 5,000, 5 millimeters, and 90 impact angle. So let's run the simulation. As you can see, it didn't even pierce through the second wall. But with the Whipple shield, it penetrated all 3 layers. And as you can see, the table results. So let's continue. We have conducted a series of virtual tests comparing our 4-layer armor and Whipple's 3-layer composite, 3-layer field armor. The results were more than convincing. The table presents the 7 of the most challenging scenarios. Let's see the results analysis between 3 key parameters, which are reliability, energy absorption, and safety margin. Our composite armor demonstrated clear superiority across all key parameters. First, reliability. Our armor stopped the threat in 5 out of 7 cases, while the Whipple armor did so only in 2. Then, energy absorption. Even in cases of penetration, our armor absorbed up to 84% of the impact angle, while its counterpart absorbed only 35%. And lastly, safety margin. Our armor used way fewer layers to protect us from the threat, which is crucial for the vehicle's survivability. Thus, during the project, we designed a concept of a 4-layer composite armor that significantly outperforms any existing analogs. Second, we created a unique software simulation that helps us verify and analyze any protection systems. And lastly, we numerically proved our practical significance, which is crucial for the safety of the future of space exploration. So, thank you for your attention.